Welcome back students to the next module of stationary waves. In this module, we are going to study about the numericals which are there on the vibrating string. To study about this numerical, let us consider the first example. It says the speed of the transverse wave along a uniform metal wire when it is under a tension of 1000 gram weight is 68 meter per second. If the density of the metal is 7900 kilogram per meter cube, find the area of the cross section of the wire. So we need to find out the area of cross section. Let us write down whatever the given data is. The first thing that is given to us is the tension, that is 1000 gram weight. To convert gram weight into the SI unit, we know that 1 gram weight is actually 10 to the power minus 3 kilogram weight. So when I convert it into kilogram weight, it becomes 1000 into 10 raised to minus 3 kilogram weight. That is actually 1 kilogram weight. And kilogram weight itself is not the SI unit. To convert it into SI unit, we need to multiply 9.8. So we get the final answer as tension is 1 into 9.8 Newton. That is, tension is actually 9.8 Newton. We know that the velocity of the wave on the string is given as 68 meter per second. Also, the density is given as 7900 kilogram per meter cube. Now what do we need to find? We need to find out the area. What is the formula that we'll require? We require the formula of velocity of a wave on a transverse string is given by V is equal to under root of T by M. Now, we have this given data, we have the formula. So let us find out the solution. We know that mass is equal to volume into density. So can I say volume can be written as area into length multiplied by density? So I have mass which is equal to area into length into density. Small m is mass per unit length, that is capital M upon small l. We also know that mass is equal to area into length into density upon length. So length and length will get cancelled and the final answer will come out to be area into density. Moving ahead, we know that velocity is under root of T by M. So can I say velocity is actually under root of T upon small m can be written as area into density. So in the similar way, V square will be T divided by area into density. Students, remember these steps once again. I'll just write it down for you. Mass or mass per unit length is given as area into density. We know that V is under root of T by M, that is T upon a rho, and V square will be T by a rho. Now we want A, so that will be T by V square multiplied by rho. Substituting all the values in the equation, tension is 9.8 Newton, velocity is 68, the whole square, multiplied by 7900. On solving this equation, we get the final answer of area as 2.683 multiplied by 10 to the power minus 7 meter square. So we got the value of area. Moving ahead to the next problem. It says a transverse wave is produced on a stretched string 0.7 meter long. That means the length is given to us and it is fixed at its ends. Find the speed of the transverse wave. That means we need to find out V when it vibrates emitting the second overtone. Now the frequency is having second overtone and the frequency is 300 Hertz. What is the given data? Length is given 0.7 meter long. Frequency is 300 Hertz. We need to find out the velocity. What is the formula that we are going to use? We know that velocity is equal to n lambda. Now, to find out the solution, we know that V is equal to n lambda, and since it is second overtone, means it is third harmonic, that is 3 loops are formed. Since 3 loops are formed, I can say that the length is 3 multiplied by length of one loop, that is lambda by 2. So it will be 3 by 2 into lambda. So I know that lambda will be 2L by 3. Now substituting this in the above equation, I get V is equal to n lambda, that is n multiplied by 2L by 3. On substituting all the values, we get this equation as 300 multiplied by 2 into 0.7 divided by 3. On solving this, we get the final answer for velocity as 140 meters per second. So student, with the help of this module, we learned the problems which were based on the concept of vibration of string. Thank you.